Hello dear students, how are you? I hope you are enjoying my online classes and as I discussed with you in my last lecture, the deleted portion of syllabus by CBSE. Now for your term 1 we are having syllabus chapter 8 and 9 only, and in today's lecture we'll start revision of chapter 8 and we'll try to finish as many topics as we can finish in approx 15 minutes time. So our first topic is for chapter 8. Your term 1 syllabus is chapter 8 and 9 according to new syllabus of CBSE. I have also discussed the deleted topics in a lecture I shared last week. Okay, you can check it from there. So chapter 8 name is motion. The first topic is distance versus displacement. तो जैसे हमने डिस्कस किया था, बहुत सारे बच्चों को याद होगा, डिस्टेंस क्या होता है? डिस्टेंस इज द एक्चुअल पाथ कवर्ड बाय एन ऑब्जेक्ट, while displacement is the shortest path between initial and final point. For example, if a person starts from point A and reaches point B going through this circular arc, and distance between point A and B is say 20 meters, then we know that radius of this circular arc will become 10 meter, and this distance is half of the distance of circumference of a circle. What is the circumference of a circle? That is 2 pi r, and half of that will become pi r. So this distance, which is actually covered by the person when he reached at point B from point A going through this semicircular arc, the distance is pi, and in place of r we can put 10. So answer is 10 pi meters, or 10 into 3.14, that is 31.4 meters. What about displacement at this point? Displacement is the shortest distance between 2 points, that is a straight line, and shortest distance between these 2 points is going to be 20 meter, that is the diameter of this semicircular arc. So the displacement is going to be 10 into 2, that is 20 meter. So that is the difference between distance and displacement. And what if the particle is moving on straight line itself? If particle has actually moved through this distance AB, that is of 20 meter, then we can say that distance is equal to displacement. The both quantities are equal in this case, is equal to 20 meter. So what you are observing from these two cases, if the object is moving in straight line and not changing the direction, then distance is equal to displacement. Otherwise, for any other path other than straight line path, can be any path. This is the shortest path, and your other path can be from A to B. Other path can be like this, or like this, or like this. Any path other than straight line path may come under a distance. So what you are observing here, that distance is always greater than or equal to displacement. So displacement is always less than or equal to distance, or distance is always greater than or equal to displacement. I hope you understood this point. Let us have one more example here. Consider a person starts from point A, moves 3 meter to right hand side to point B, and then moves downward direction 4 meters to point C, numerical second. And you are interested in calculating distance and displacement. We know that actual path covered is known as distance, so actual path, that is distance, is going to be 3 plus 4, that is equal to 7 meter, while displacement is this AC. AC is displacement, so distance is AB. I will write with black color about distance. So distance is your AB plus BC, while your displacement is going to be, displacement is equal to AC. And because this is a right angle 90 degree, this in this problem we can apply Pythagoras theorem, and according to Pythagoras theorem, AC square is equal to AB square plus BC square. So AC square is equal to AB 3 square 9 plus BC 4 square 16, that is equal to 25. So your AC is equal to square root of 25, that is 5 meter. So displacement is 5 meter in this case, and distance is 3 plus 4, 7 meter. I hope you understood this point. Let us move on to the next point. Our next point is velocity, concept of velocity. So let me erase it for you very quickly. You can always go back and listen again. That is the benefit of having recorded video. So second point, we are having velocity, and I will also be discussing the concept of average velocity. So what is velocity? Velocity is defined as rate of covering or rate of change of displacement. Velocity is defined as rate of change of displacement. So V is equal to d2 minus d1 displacement, d2 minus d1 change in displacement divided by time taken. That is the formula for velocity. So if a particle is at position d1, that is 10 meter, and it reaches to a point d2, that is 20 meter, and the particle takes a time of 2 seconds in doing so, so we can say that velocity is equal to 20 minus 10 by 2, that is 10 by 2, that is 5 meter per second. So unit of velocity is meter per second. And how can we define 1 meter per second? So if an object covers 1 meter displacement per second or in 1 second of time, then we can say that velocity of object is 1 meter per second. So you can define 1 meter per second, definition of unit velocity 1 meter per second. One more important point which I would like to discuss with you before moving ahead. That we just studied displacement. Displacement is a vector quantity, while distance is a scalar quantity. So displacement is a vector quantity and displacement is a vector quantity and distance is a scalar quantity. What are the points of difference between them? Distance versus displacement versus distance. Displacement, as you know, is a vector quantity. First difference is that, while distance is a scalar quantity. In vectors we have direction associated. In distance no direction is associated, डायरेक्शन एसोसिएट नहीं होती. Number 3, displacement can be positive, negative or zero, while distance can be zero or positive. It cannot be negative. Fourth point, displacement is always less than or equal to distance, while distance is always greater than or equal to displacement. So as you study these basic differences between displacement and distance, why I am telling you? Because velocity is rate of change of displacement, so velocity is a vector quantity, while a speed is a scalar quantity. So you can also write these different points of difference which are between displacement and distance. You can write them for velocity versus speed. Only on this fourth point you will write I think you can write in the same manner, because I have not mentioned displacement here. So here you can write, in case of speed, speed will come, or in case of distance, distance will come. So distance or speed, whichever you are writing, is always greater than or equal to displacement versus velocity. So you can write corresponding term: distance, displacement, or speed, velocity. So this is very important to understand the difference between scalar and vector. Displacement and velocity are vector quantities, while distance and speed are scalar quantities. Okay, so after understanding this velocity, let us move towards the average velocity. What is average velocity? Average velocity is defined as total displacement covered per unit, total displacement covered divided by total time taken. So the formula for average velocity, the AB subscript is representing that velocity is average velocity, is equal to total displacement divided by total time. That is your formula for average velocity. And similarly, if you will take distance in place of displacement, then it will become speed. As I told you, that rate of change of displacement is velocity and rate of change of distance is speed. So if you are taking total displacement by total time, that is average velocity. But if you are taking total distance divided by total time, that is your average speed. Let us have a quick numerical on this formula, average velocity. So let us consider that an object covers from A to B distance of 1 kilometer with a speed say 5 meter, with a velocity say 5 meter per second, and B to C 2 kilometer of distance with a speed 10 meter per second, and we are interested in finding out the average velocity. So we'll apply the formula total displacement by total time. But you must note here that displacement is given in kilometer while time is given in meter per second. So we must convert kilometer to meters. So we'll apply the formula average velocity is equal to total displacement by total time. But what is total displacement? Total displacement is equal to 1000 meter plus 2000 meter, that is 3000 meter. We converted it from kilometer to meters. तो ये मिस्टेक बच्चे बहुत कॉमन करते हैं कि किलोमीटर से मीटर में कन्वर्ट करना भूल जाते हैं. And for calculating total time, we know that what is the time it will take in covering this 1000 meter distance. 1000 divided by 5. Distance by displacement by speed, you will get the velocity. So 200 seconds it will take in reaching from A to B, and then plus 2000 divided by 10, again 200 seconds in reaching from B to C. So what is total time? Total time is going to be 400 seconds. So in 400 seconds particle is reaching from A to C, covering 3000 meters of distance. So your average velocity is going to be total displacement, that is 3000 meter, divided by total time, that is 400 seconds. So your answer is 15 by 2. 2 to the 4, 15 by 2, or 7.5 meter per second is your average velocity. So that is how you can solve these numericals. I'll take little longer than my average lecture because it's a revision lecture, so we are going at a pace. You can hold here and have a look. Meanwhile, let me move to the other topic really quickly. The next point which we are going to discuss is uniform motion versus non-uniform motion. Okay, बहुत कॉमन क्वेश्चन है, बार बार पूछा जाता है. तो यूनिफॉर्म मोशन क्या होता है? यूनिफॉर्म मोशन आपका वो मोशन होता है जिसमें आपकी जो स्पीड या वेलोसिटी जो है वो कांस्टेंट रहती है, उसे हम यूनिफॉर्म मोशन कहते हैं. उसकी स्पीड चेंज नहीं होती है, कांस्टेंट स्पीड से ऑब्जेक्ट चलता रहता है. यूनिफॉर्म मोशन के लिए हमारे पास बहुत सिंपल इक्वेशन होती है. डिस्प्लेसमेंट इज इक्वल टू स्पीड इनटू डिस्प्लेसमेंट इज इक्वल टू वेलोसिटी इनटू टाइम. दैट इज वेरी सिंपल इक्वेशन फॉर यूनिफॉर्म मोशन. You can use it like velocity is equal to displacement by time, or time is equal to displacement by velocity, or displacement is equal to velocity into time. But for non-uniform motion, we are having a changing velocity. It may be increasing or it may be decreasing. While in uniform motion, we are having constant or same velocity, which is constant. So we know that acceleration is defined as change in velocity by time taken. So in uniform motion, acceleration is equal to 0. You remember that I asked this question in last time in your UT1. What is the difference between uniform motion and uniform motion in terms of acceleration? So acceleration is 0 in uniform motion and acceleration is non-zero in case of non-uniform motion. So in non-uniform motion, as your velocity is changing, your acceleration is non-zero. And in non-uniform motion, acceleration can be positive or negative. So if your velocity is increasing, your acceleration is positive, and if your velocity is decreasing, your acceleration is negative. So if velocity is changing, we can always calculate acceleration as final velocity minus initial velocity divided by time taken. This is going to be your formula for non-uniform motion. If we consider final velocity as v and initial velocity as u, what we get, v minus u is equal to at, or v is equal to u plus at, which is also your first equation of motion, which we can derive using your graphical method. And in non-uniform motion, we are having two more equations. S is equal to ut plus half at square, and v square minus u square is equal to 2as. So these equations are also in your syllabus for non-uniform motion. Next point, we are having acceleration, which we have already discussed here. So fourth point, acceleration, is also covered. The unit of acceleration is represented by A, and unit of acceleration is meter per second square, because as it is already the difference in velocity is in meter per second and divide by time another second gives acceleration unit meter per second square. We can also write it like meter second minus 2. Okay, I hope you got it, and I will be sharing one more video lecture with you of this chapter at motion. And do not get surprised if you will also get my video lecture even after Monday and Tuesday. So Monday and Tuesday I will be having a live session with you in which you can have a revision of chapter 8 and 9, and even after I'll try to post 2 more videos so that entire revision is finished by this week only of these 2 chapters, and you are all set for your term 1 examination. Okay, if you are having any doubt you can always contact me. Like always, thanks for watching. Take care.